Okay, section 12.1, composite functions. So we're launching into a new chapter now. And in this first section, we have two things to talk about. The first is we need to be able to construct composite functions. Composite functions. And the second is we're going to look at compositions. And that's what a composite function is. We call it a composition. So this is compositions of three or more functions. So before we launch into compositions specifically, we're going to talk a little bit about the algebra of functions. Now we're used to doing algebra with numbers, with variables, and now compositions are a special operation that functions get. So we just want to look at the other operations that functions have. Now we've done all of these in one way or another. In this class and in your previous math classes, you've done these. You just maybe didn't know that you're thinking about them or should be thinking about them as algebra and functions or function operations. So if f of x and g of x are two functions, then we can construct the following. So these are the base operations that we usually see. The first one is the addition, f plus g of x. Now this is still function notation here. I completely understand that this is a horrible notation. So this is the combination of f and g using addition of x. Now we won't usually write it like this. You may see it in your homework where it says form this function, but know that this just means take f of x and add it to g of x. And this notation is much more common because it makes a lot more sense than this. So this is f plus g of x, which is the same as just saying f of x plus g of x. So this makes a lot more sense to me personally and to most people, I think. And so if there's addition, there's also subtraction, f minus g of x. Just like with addition, this is just f of x minus g of x. There's multiplication, f times g of x, which is just f of x times g of x. And there's also division, f over g of x, which is just f of x over g of x. Now this one has a special requirement since we are doing division. We need g of x to not equal 0. And if g of x equals 0, then we say f of x over g of x is undefined. So a lot of times it'll say in the homework, form these four functions if it's possible, and they add that if possible because this one, the first three here, f plus g, f minus g, f times g, those can always be made no matter what. But when you do division, just as we're used to with rationals, we have to make sure our denominator is not 0, and if it is, you just say it's undefined. So let's work with these a little bit here. Got a little practice question. So let f of x equal x plus 2 and g of x equal 3x plus 5. And I would like you to form the four functions we listed above. All right, so all four of these. So you should pause the video here, try this out. Shouldn't take too long. You're just following these rules. Excuse me. And I'm going to go over them in a second here. I'm going to go over them now. Okay, so I'm going to start going through these. Hopefully you've come up with your answers. So number one, f plus g of x is just going to be x plus 2 plus 3x plus 5, which is 4x plus 7. F minus g is x plus 2 minus 3x plus 5. Now this is an important part here in the subtraction algebra function. We have to make sure that we put parentheses around the second function because we're subtracting the whole thing, not just the first term. So make sure you got those parentheses. And this becomes x minus 3x is negative 2x, and 2 minus 5 is negative 3. So negative 2x minus 3. F times g of x is going to be x plus 2 times 3x plus 5. And we can distribute that out and get 3x squared. This is going to be plus 5x plus 6x, or plus 11x plus 10. And then f over g of x will be x plus 2 over 3x plus 5, with the domain restriction that x cannot be negative 5/3. So whenever you form your division, you want to look at where that g of x is 0, because we don't want that to be the case. So g of x can equal 0, which means that x can't be negative 5/3. Oops. So those are our four algebra functions. So I said this kind of quickly at the beginning. Function composition is an extra operation. So we have addition, we have subtraction, multiplication, division. Functions, because of the way that they're set up, because they take an input, they get a fifth operation, and it's called composition. So this is function composition. And this is all only exists because functions take an input. Functions take an input. We can compose. So composition is the closest thing to true combination or combining of functions. All of these, f minus g, f times g, f over g, it's kind of taking each individually and mashing it together, not truly combining it. So composition, just like this, has a fun in quotation marks there. It's f circle g. So it's not the same as multiplications. It's not a dot. It's a true circle. And this equals f of g of x. And we can compose it the other way as well. We can do g circle f of x, which would be g of f of x. Now these two things are not the same. So the best way that I remember this is I treat the circle as an O to tell me what order I should be going in. So this one is f of g. So it's f of g. And this one here is g of f. G of f. So you can treat the circle as a stand-in for of. So it's f of g, which means f is on the outer. G of f means g is on the outer. So that's how we set up compositions. Let's go ahead and practice composing several functions a couple different ways. So we're going to let f of x equal x minus 1 and g of x equal 2x squared minus 3. And we are going to form f circle g, g circle f, f circle f, and g circle g. So this is adding more compositions. You can compose a function with itself. So let's start with f circle g. So again, f of g of x. So the way that compositions work is we take the second function after the circle, the of, and that becomes the input for the outer function. So g is going to get plugged into f. So to make this pretty explicit, you can change first, don't change the outside, just start by changing the inside. So g of x is this whole thing now, 2x squared minus 3. And so now, due to function notation, all of our x's in f get replaced by 2x squared minus 3. And so this is 2x squared minus 3 minus 1. Our x in f became this thing. And so our final answer is 2x squared minus 4. So that's our f of g. G of f of x does the same thing except in the opposite. So instead of plugging g into f, we're now plugging f into g. So this is g of x minus 1. So all of our x's in g, specifically this one, is going to get replaced by x minus 1. So this is 2 times x minus 1 squared minus 3. And then expanding that out, we have 2 times x squared minus 2x plus 1 minus 3. And here we have 2x squared minus 4x plus 2 minus 3 is minus 1. And that's our G circle F. So moving on now to F circle F. This is f of x. So this is going to be f of x minus 1, which is going to be x minus 1 minus 1, or just x minus 2. And G circle G is going to be G of x, which is G of 2x squared minus 3, which is 2 times 2x squared minus 3 squared minus 3. So expanding that out, we have 4x squared minus 12x plus 9 minus 3. And then this is going to be 8x squared minus 24x plus 18 minus 3 is plus 15. So that's how we compose. Once you get the hang of composition, it's really not super complicated. It just gives us a new way to look at functions and to work with functions. A lot of really important functions that we see in higher level mathematics are compositions of two already known functions, because maybe one function depends on the other, or one function's input depends on the other. And so we can construct these compositions to look at more unique functions as we move along. So, in your homework, a lot of it is just going to be forming these compositions, or what's going to be more interesting is decomposing. So taking this, for example, and figuring out what's the G and G. What was the inner and what was the outer? And so you'll have some homework problems like that. And it's just really undoing what we did first. And if you started with this one, for example, also I realized I made an error here. Looking at this, 2x squared is 4x to the fourth. 4x to the fourth. This should be squared and squared. Let's make that little correction here, because this is a square here. X squared is x to the fourth, and then this should be times x squared. All right, so let's look at how do we compose three or more functions. Or more functions. So we're going to look at how we do this with three. And if you can understand how to compose three functions, you'll be able to compose any number of functions you want. So we're going to let f of x, g of x, and h of x be functions. Then f circle g circle h of x. This is, you read this left to right, so this is f of g of h. So f of g of h of x. And now we need to close these parentheses, close these parentheses. We do a couple others. We can do f circle h circle g of x. So again, this is left to right, f of h of g. So f of h of g of x, close parenthesis, and then we can get any order of these three that we want. So we could do g circle f circle h of x. We could do g circle h circle f of x, and we could do h circle g circle f of x, and h circle f circle g of x. So we have the format here, so try and fill out the rest of these four on your own. So pause the video real quick, then just see if you can write it out in the right form. And I will go over them now. So g of f of h, g of f of h of x, close parenthesis, g of h of f, is g of h of f of x, close parenthesis, h of g of f, h of g of f of x, close parenthesis, and then h of f of g, h of f of g of x, close parenthesis. So if you are composing three functions, you can make these 6 compositions. For every extra function you add, so let's say we added another one at k of x and we wanted to compose 4. Well, it turns out you can make 24 different compositions with 4 different functions. And every time you add, it's a multiplicative increase. So if we have 5 functions, we can make 120 different compositions. If we have 6 functions, we can make 720 different compositions. So you can see it gets out of hand fast being able to make all of them. So for the most part, if it says form all compositions possible with 3 or more functions, obviously we could be composing 2 and 1, so f of g, or g of f. Those aren't as common when you're asked to do all of them, and I certainly won't be asking you to form every composition possible of anything other than 3. 6 is a manageable number, 24 is a bit much, and anything more than that is just ludicrous. So this is how you compose more functions though. See if you can compose 4 functions. There's at least 1 or 2 homework problems that are going to ask you to compose 4 functions together in a very specific way. But as long as you treat the circles as O's for of, you can never go wrong. You just, every circle you replace it with a parenthesis, and inside that parenthesis goes the very next letter. And you just go left to right. Right, so that's the end of 12.1.